Microsoft may be preparing to change what it means to own a computer, not by increasing the price of Windows, not by placing a visible meter beside your processor, and not by sending you a monthly bill for every calculation your CPU performs. The transformation could be much more subtle. You purchase the computer, you pay for the processor, memory, storage, electricity, and internet connection. But an increasing number of the experiences running on that computer may be controlled by hardware eligibility rules, Microsoft accounts, cloud services, and recurring AI subscriptions. Your machine still belongs to you physically, but its most valuable capabilities could remain locked behind Microsoft's servers. That is the real meaning of the so-called CPU tax. Before going further, one fact needs to be made clear. As of July 22, 2026, Microsoft has not publicly launched an operating system called Windows 12. Its official release information continues to identify Windows 11 version 25H2 as the mainstream release, while version 26A1 is designed primarily for new hardware, rather than as a normal feature update for existing computers. There's also no confirmed Microsoft plan to move essential Windows kernel operations into the cloud or charge users for individual CPU cycles. But that does not mean the concern is imaginary. The architecture of the next Windows business model is already being constructed inside Windows 11. Copilot plus computers, neural processors, cloud-connected assistants, premium AI plans, strict hardware classifications, and subscription-based productivity features are creating a new division between what your computer can technically perform and what Microsoft permits it to perform. Windows 12 may not yet be an official product, but the economic system people associate with it is already arriving. To understand what is happening, think back to the launch of Windows 11. Millions of computers were powerful enough to browse the web, edit videos, run professional software, and play modern games. Yet many of those machines were officially excluded from the upgrade because they lacked supported processors. Secure boot configurations, or TPM 2.0. Microsoft presented these requirements as security protections. TPM 2.0 provides hardware-backed encryption, identity protection, BitLocker support, and stronger resistance against certain attacks. Those are genuine advantages. However, the decision also established an important precedent. A computer could remain fast, stable, and useful while being declared officially incompatible with the newest version of Windows. Windows 11's published minimum requirements include a compatible processor, at least 4 gigabytes of memory, 64 gigabytes of storage, secure boot capability, and TPM 2.0. For ordinary users, that changed the upgrade conversation. The question was no longer simply, is my computer fast enough? It became, has Microsoft placed my hardware inside the approved category? That distinction becomes even more important in the AI era. Microsoft's Copilot plus PC classification requires a neural processing unit capable of at least 40 trillion operations per second, along with a minimum of 16 gigabytes of memory and 256 gigabytes of storage. The CPU and graphics card are no longer the only components that determine whether a machine receives Microsoft's complete Windows experience. The NPU has become a new gatekeeper. A powerful desktop processor that cost hundreds of dollars only a few years ago may still outperform a thin laptop in traditional workloads. It may compile code faster, render video more efficiently, and deliver better gaming performance. But without a qualifying NPU, that desktop may not receive the same AI features. Microsoft officially distinguishes Copilot plus PCs through their 40-plus TOPS NPUs and reserves several Windows AI experiences for machines meeting that classification. That is the first layer of the CPU tax, hardware eligibility. The user is not paying Microsoft for every processor cycle. Instead, the user is encouraged to replace hardware that remains perfectly functional because the latest software experiences recognize a different category of silicon. This is how software policy can manufacture hardware obsolescence. The old computer does not suddenly stop working. It simply becomes a second-class Windows machine. Some features arrive later, some remain unavailable. Others may technically function, but receive no official support. Over time, the gap between standard Windows computers and Microsoft's preferred AI computers becomes large enough that upgrading begins to feel unavoidable. And this time, the upgrade is not merely from one processor, generation to another. Microsoft and PC manufacturers are selling an entirely new component as essential, the NPU. An NPU is highly efficient at running machine learning workloads. It can process camera effects, language models, image recognition, transcription, semantic search, and other AI tasks while using less energy than a conventional CPU or graphics processor. There are legitimate technical reasons to use one. The problem begins when hardware optimization becomes feature exclusion. A feature may be designed to run efficiently on an NPU, but that does not always mean it would be impossible to run on a GPU or powerful CPU. Sometimes the alternative would be slower, sometimes it would consume more electricity, sometimes the experience would be less polished. But limiting it entirely to a certified hardware category transforms a performance recommendation into a commercial boundary. That boundary benefits Microsoft, processor manufacturers, and PC brands simultaneously. Microsoft gains a controlled platform for deploying AI. Chip companies sell a new generation of processors. Computer manufacturers receive a reason to convince users to replace machines that might otherwise remain in service for several more years. The user pays the first tax at the electronics store. But the second tax begins after the computer is switched on. AI systems are expensive to operate. Large language models require enormous amounts of computing power, memory, networking infrastructure, cooling, and electricity. Even Microsoft cannot provide unlimited access to its most advanced cloud models without eventually recovering those costs. That recovery happens through subscriptions, usage limits, premium tiers, enterprise licenses, and bundled service plans. Microsoft currently offers consumer Microsoft 365 subscriptions with different levels of Copilot access, including a premium plan priced at approximately $199.99 per year in the United States. Its commercial Copilot offerings can add substantial per-user monthly costs, while Microsoft 365 Copilot has also been advertised at around $30 per user per month for qualifying organizations. Prices and availability vary by country and plan. This is the second layer of the CPU tax, recurring intelligence. The operating system may still boot without a premium subscription. Files may still open. Applications may still run. But the most heavily promoted experiences could increasingly depend on paid AI access. Imagine a future Windows computer with an expensive processor, a powerful graphics card, and a dedicated NPU. The hardware is already capable of processing language, images, documents, audio, and automation locally. Yet the highest quality assistant, the largest models, deeper Office integration, agentic workflows, or expanded usage limits may still require a subscription. The user has purchased the silicon. The user supplies the electricity. The user provides the data. But the intelligence layer remains rented. That is where the metaphor of taxing the CPU becomes useful. Microsoft does not need to charge for every calculation directly. It only needs to place the most valuable workflows behind services that convert local hardware activity into recurring revenue. Every time AI drafts a document, summarizes a meeting, searches through email, generates an image, analyzes a spreadsheet, or controls an application, Microsoft has an opportunity to attach that action to an account, entitlement, cloud allowance, or paid plan. The computer stops being a finished product. It becomes an access terminal. However, the situation is more complicated than the most dramatic headlines suggest. Microsoft is not moving everything into the cloud. In fact, it is investing heavily in on-device AI. Windows ML allows developers to run supported AI models locally on Windows hardware. Microsoft promotes local inference as a way to reduce latency, protect private information, eliminate cloud costs, and allow applications to function without an internet connection. Features such as Recall and Click to Do also perform important analysis locally on compatible Copilot Plus computers. Recall can capture snapshots of a user's activity and make that history searchable. The feature attracted enormous criticism when it was first revealed because a system that remembers activity across applications creates obvious privacy and security concerns. Microsoft later redesigned its protections. Recall now requires the user to opt in, uses Windows Hello authentication, encrypts its database, and stores snapshots locally. Microsoft says internet or cloud access is not required to save and analyze those snapshots, and users can pause, filter, delete, or remove the feature. Click to Do similarly analyzes selected screen content locally when activated on supported hardware. These details matter because claiming that Microsoft is already uploading every essential Windows process to the cloud would be inaccurate. The more realistic future is hybrid computing. Small, frequent, private, or latency-sensitive tasks happen on the device. Large, complex, frequently updated, or commercially valuable tasks are sent to the cloud. Your NPU handles background recognition, indexing, camera processing, and smaller AI models. Microsoft's servers handle advanced reasoning, enormous context windows, enterprise data integration, model updates, and computationally intensive generation. On paper, that is a sensible architecture. Local processing improves speed and privacy. Cloud processing provides access to models far too large to fit comfortably on an ordinary computer. But hybrid computing also gives Microsoft extraordinary control over where the line between local and cloud is drawn. A feature that runs locally today could receive a more capable cloud version tomorrow. A free model could be replaced by a limited allowance. A premium assistant could become deeply integrated into File Explorer, Settings, Office, Windows Search, security tools, and system automation. The basic feature remains available locally. while the version users actually want requires a subscription. This pattern already exists throughout the technology industry. Cloud storage begins with a free allowance before encouraging a paid upgrade. Streaming platforms place premium quality behind higher tiers. Mobile applications offer basic features while reserving automation, exports, or advanced tools for subscribers. Windows could adopt the same structure at operating system scale. The danger is not that the computer becomes completely useless without payment. The danger is that inconvenience is carefully engineered into every unpaid experience. Consider Windows for search. A traditional operating system searches file names, metadata, and indexed text. An AI-powered version could understand vague questions, identify objects inside images, recall the context of previous work, summarize documents, and retrieve information scattered across local files, cloud storage, email, calendars, and workplace applications. The first layer could run locally. The most useful layer may require Microsoft Graph, access, cloud models, OneDrive integration, and a paid Copilot license. Or consider system support. Instead of displaying an error code, Windows could allow an AI agent to examine logs, identify a broken driver, change settings, repair an application, or communicate with a vendor. That sounds valuable. But what happens when basic troubleshooting remains free while autonomous repair becomes a premium service? The same question. Applies to security. Microsoft could use local models to identify suspicious behavior, while advanced cloud analysis checks files, accounts, devices, and organizational activity against constantly updated threat intelligence. Again, the technology has legitimate advantages. But once security, productivity, search, and system control are intertwined with recurring AI services, refusing the subscription may become increasingly difficult. Microsoft would not need to force users to subscribe through a single dramatic decision. It could make the free version slightly less capable every year. This is how platforms create dependency. First, the feature is optional, then it becomes convenient. Then software begins to assume that it is available. Finally, turning it off makes the computer feel incomplete. The greatest risk is not cloud computing by itself. The risk is losing the ability to choose where computation occurs. A sovereign computer is a machine whose owner can decide which software runs, where data is processed, how long information is stored, and whether an internet connection is necessary. A dependent computer performs important operations only after receiving authorization from a remote company. Under the dependent model, ownership becomes conditional. You may own the processor, but Microsoft controls the service endpoint. You may own the storage, but